Okay, so once you know how to calculate standard deviation, what it helps you figure out is normal distribution. So what that means is that if you take any data set, there will be a normal curve to that data set. And what happens is the majority of the data should come out kind of in the middle, okay, an average of things. So if you get samples like this that are not following this pattern, you'll either, so this would be considered a normal curve, right? It's kind of right down the middle. You've got a large amount of data right around the average, and little, they call these the tails that are off to the left and right. If something is skewed, so say it's skewed, this is skewed right, that means that you have a lot of higher data values in there. So like, for example, if you gave a test and it was really skewed to the right like that, the test's probably too easy. Something's off with it if everybody is scoring really high on average. If it's skewed to the left where it was going like this, where everybody failed a test, usually there's something up with that too, right? So there's something going on if your average, say, is down here in 30, something's going on, okay? Typically. All right, so areas under a normal curve, and the reason they're called a normal curve is because they do have a set percentage that should be in that data set. So here's your curve, okay? So all of this shaded area underneath the curve is 100% of your data. So your data has to fit in here somewhere. And here's your low end, here's your high end. What a normal distribution curve says is here's the middle, here's your average right here. Let me see if I can focus that in farther. Okay. Right in here is your average, right? Right down the middle. So whatever our standard deviation is, that means that the average plus 1 standard deviation is going to be right here. Okay. And your average minus a standard deviation is going to be out here. 68% of that data will fall. The way we say it is it will fall within 1 standard deviation of the mean. Okay? And that information is here. So 68%. So each of these sections, what's 68 divided by 2? 34. So you'll have 34% right above, 34% right below the average. Okay. About 95% of your entire data set will fall within 2 standard deviations. So 2 standard deviations would be 2 above and 2 below your average. So 95% of your data should fall within these 2 sections. Okay? That would be a normal curve. So, and then the remaining 5% will be off in the tails. 99.7% falls within 3 standard deviations of the mean. Okay? So if you split these percentages up, there'll be 34% and within 1 standard deviation, plus or minus. That second little section will be 13.5%. Third standard deviation, there's 2.35% there, and then out in the tails, that's only 0.15% of your data. So we had a speaker last week, X knows that he's an inventor. He came and they invented they have an automatic pizza sauce dispensing machine that Costco uses. Okay, so they put it on a little wheel, it spins around and it puts the sauce on. That machine is accurate to within 1/10 of an ounce. Is that what he said? 1/10 of an ounce of sauce. So every time it puts sauce on that pizza, it is accurate, really, really accurate. When they package food, if you get a box, this is where standard deviation comes in the real world. One of the ways. If you buy a box of cereal and it says 16 ounces, it says that box is 16 ounces, okay? When they sell that to you, it has to be within 1 standard deviation of that. You can't get a box of cereal that's 12 ounces or a box of cereal that's 18 ounces. So if they determine that the standard deviation for that box, so say it's 16 ounces is what it needs to weigh, and they say the standard deviation is 0.1 ounces, that means that it needs to fall between 15.9 and 16.1 ounces. And that's actually a legal thing. That is, when they package products, they have to reflect accurately what's in the package. And when they don't, that's committing fraud. And about 3 or 4 years ago, there were companies, big companies, that paid a lot of money in fines because they were not selling the amount of product in their containers that they said they were. And that's a big deal. Yes, Jillian?
So is that kind of what it is for like chips? So
Any product.
they always have
Any product.
chips.
Any product, but it has to fall within a certain weight. If it says that something's going to be a certain weight, can't be exactly 16 ounces on the nose every single time. So they give them, okay, well, we're going to give you a range of 15.9 to 16.1, but your packages have to fall within that range. Otherwise, you're selling less of a product than you say you are for the same amount of money, and that in and of itself is committing fraud. So you can't do that. And there are jobs where people go and randomly will take packages off shelves and go and weigh the product and make sure that what's in the box is what says it's in the box.
So if it's not, what happens? Like,
They pay fines. They usually will get a warning, and then one of the big ones was Procter & Gamble. Procter & Gamble sells hundreds, probably thousands of products, and they were caught doing that. So, and it may be intentional, it may be a packaging manufacturing mistake, whatever, but they're still responsible for it. Okay? All right, so a normal distribution has a mean of X and a standard deviation of little O with the curly. Okay, so what that means is your average is going to be here. Here's your average, right in the middle. Okay, I'm going to take the standard deviation, this range, which is 34% above and 34% below, which is a total of 68%, right? I'm going to take that average and add a standard deviation, one standard deviation, or I'm going to take that average and subtract a standard deviation. And it will actually be easier once we put actual numbers to it. Okay. Then the same thing for the next range. I'm going to do the average plus 2 standard deviations, or the average minus 2 standard deviations. And then to the third. Okay. So there's also something in when you get into more advanced statistics, you'll calculate something called a z-score, because obviously this is an average bell curve. Is everything going to come out exactly nice whole numbers?
Yes.
No. So a z-score, in this case, a z-score, this would be a z-score of -1. This would be a z-score of 2. Obviously, there's a lot of in between, right? You can have a z-score of 1.4. You can have a z-score of -2.7. Okay, but that is in general the z-score. It's how many standard deviations you're away from the average. Okay. All right, so let's go down to the example, and once we put actual numbers to it, it'll make more sense. So the score on an exam for an entrance to the firefighter program are normally distributed with a mean of 200 points and a standard deviation of 20 points. Okay? So let's just draw that curve and see what that would look like. So right in the middle, I would have what? What's my average? 200. Okay? Every range is going to increase or decrease by how much? What? 20. Why is it 20, Andres? That's my standard deviation. Okay? So the average exam score is a 200. What would the next range be? 220. So that's one standard deviation. What's one above? What's one standard deviation below? 180. Okay? And then, and this is 34%. This is 34%, right? The next range is going to be the 13.5%. Does everybody understand why that's 13.5%? Okay, if I take 68, right? I know that within two standard deviations it's 95%, right? So 95, oops, minus the 68 I can already account for. So there's 27% that has to account in those two ranges right there, and I just have to divide that by 2, and I get 13.5. Okay? So Andreas, what are the values for that lower range? 160, another 20 below, right? And then another 20 above would be what? 240. And then in that next range, so same thing, now I've accounted for 95%, right? So 95 minus 99 let's flip that around. 99.7 minus 95%, 4.7, and I've got to divide that by 2, so I get 2.35. So that's in here. What do all of these percentages have to add up to? They have to add up to 100%, right? You have to account for every value in your data set. Okay, so Andreas finished it out. What would be my last range? 140 down here, and what would the high end be? So what that means is, on average, the lowest score that's going to be scored on that exam is a 140, and the highest score would be a 260. But the bulk of them sit right in here. So if I were to draw that curve, it would look something like, let's see if I can do this. Hey, that was pretty good. Okay, and then your ranges would be in here. Okay, so now what they want to know is about what percent of the candidates score lower than 160 points. So here's 160. I'm just trying to calculate the percentage of candidates that score lower than that. How am I going to find that? I'm just going to add those two percentages together, right? So I've got 0.15 plus 2.35 is going to give me 2.5%. Okay? Candidates who score above 220, zoom that out a little bit. Candidates who score above 220 are admitted into the training program. About what percent of the candidates are accepted into the program? So here's my 220. Everybody who's above that gets accepted in. So how am I going to find that percentage? Just add them up, right? So I've got 13.5, 2.35, and 0.15. So that gives me a 1. So about 16% of the candidates are admitted in. That's probably an accurate percentage of people who get into Fire Academy off examination, because it's pretty low. I think it's actually lower than that in California.